There's a Slovenian company called PIPISTREL that by the end of the year is going to be launching the world's first electric-powered two-seater aircraft. And I'm talking to Tine Tomazic. What is unique about this new aeroplane of yours?
Hello, and a warm welcome to all viewers from the PIPISTREL company. I'm now in the research and design where I work. What's unique? As you already pointed out, it's the first two-seater electric-powered aircraft. And it's also, we believe, the first electric aircraft to be actually useful for the customers, for the pilots.
Now this is amazing. It's got a 30 kilowatt motor, and apparently recharging the battery takes approximately as long as recharging a cell phone.
True. Under a normal electrical network, it takes about 3.5 hours from zero charge to full charge, but you would rarely be at zero charge upon landing because you do need some reserve just in case. So about 2 hours, 2.5 hours is a typical recharge scenario.
So there's a video of the aircraft taking off and landing on your website. And but now, just getting back to the battery, that must be quite an expensive part of the overall cost of the aircraft, I would imagine. Roughly what proportion is it of the aircraft cost?
The aircraft will sell for the same price as the internal combustion engine counterpart, so we already produced the version of the aircraft with a normal engine, so to say. It goes for 85,000 euros and on with the options. So this will be the price that we are aiming at also for the electric version, and the batteries are about between 5 and 7% of this cost.
Now the fuel-powered version of that aircraft is called the PIPISB, is that correct?
No, that's not correct. The fuel-powered version is called the Taurus 503. So instead of the Electro suffix, it's the 503 because of the engine, which is called the Rotex 503, that's used on board that aircraft.
I see. And so because I know you have a number of world records achieved, which of the aircrafts did that happen with?
First of all, we offer two ranges of aircraft. One is the motor glider range, represented by the Sinus and Virus aircraft family. So this has the conventional engine at the front construction, and there are touring motor gliders. So this means that targeted at pilots want to travel around, but also do gliding. The efficiency is high enough for a glide ratio between 25 and 30, actually. And the second range is self-launching gliders, where we have the single-seat Apis and the two-seat Taurus, now also electrified into the Taurus Electro. We have a number of world records set already with the Sinus, namely the first around-the-world flight in this light category. The Virus, namely, was proclaimed the world's most efficient aircraft last year at NASA's PAV challenge, which you might have heard of. Apis holds 10 official FAI world records in gliding in its category, and I'm sure that the Taurus, which is the youngest of the product line, will still show its fantastic handling and gliding characteristics, also in terms of some world records, we believe.
So Tina, has PIPISTREL been around for quite a long time, it sounds like?
PIPISTREL started in 1987, actually, with powered trikes, and we've come a long way in those 20 years, roughly 20 years. And we are now known as the world's most versatile light aircraft producer. We do everything from research and design, testing, production, delivery of all components, including the propellers.
And there's an excellent article, I see you're featured on the BBC website, and the article sort of gets into discussing the future of commercial travel and reducing traffic congestion and this kind of thing. And the article sort of suggests that potentially an aircraft like yours, like the Taurus Electro, could maybe be used in the future for commuting by the average user. What's your comment?
Well, there will be a number of hurdles to overcome. I think that the biggest one will be regulating air traffic when it comes to the masses. So there will be a lot of small flying machines zigging and zagging over the skies, and you don't want them to appear too close to one another. So this will be the major hurdle. Otherwise, yes, there will be a need in general for a new, more efficient type of propulsion, probably electric or some other source which is not yet developed. And this will yield for a very efficient kind of aircraft, which Taurus Electro already is. I think that the future is coming. We are one of the first to show that it's actually possible to fly on electric power.
And how much space does one need to land an aircraft like this? How big does the landing strip have to be?
Well, this depends on the skills of the pilot, but we usually do it within 200 meters.
honestly. And you also sell trikes as well.
True, yeah, we still produce trikes, although most of them ship out as kits. These flying machines are quite easy to assemble, and this is good fun to certain people. So they buy a kit that's components and they assemble it on their own.
And which would be more suitable as somewhat of a commuter type aircraft, in theory?
Yes, the commuter, in my view, should have characteristics of near vertical takeoff and landing, so not a lot of space to operate, and it should carry between 2 and 3 people at most. This is what we see also with cars now. It's not too often that you see, let's say, 3 or more people aboard a car. So if we transfer this to the aviation, it would be more or less the same situation, I believe. And it should be very user-friendly. So, you know, piloting is still a skill that not too many people are involved with, and driving a car is quite something different. You want to approach the idea of driving a car to work into aviation by making things really straightforward and easy. This means that you take some workload from the pilot actually away and allow automation systems to step into the game.
Yeah, it sounds like it's very computerized and automated. Just briefly describe what it's like, what it would be like for somebody who's never flown before.
Well, I have to point out that this technology, let's say automation, is not involved a great deal in our aircraft because it is still a recreational product. We want the pilot to have fun, so we don't want to take the obvious things away from him, so we need to let him do the flying. We introduce systems automation in handling of the various systems on board, like the motor, the monitoring so that all the temperatures are okay and that the alerts only pop out when really necessary to reduce the workload and to have more fun. I could point out our system of retracting and extending the engine in and out of the fuselage for the self-launching range. It works using 2 switches, literally. So one is to either start or stop the engine for running, and one is to put it inside of the fuselage, and one is to put it out. So that's it. It really selects just the position of the engine in or out and stop and run. So that's it.
Yeah, it's a great, unique design, and that video off your website, you know, shows very well how that the propeller comes out and does its thing. So it's roughly £67,000, and that's for the basic aircraft. And what's an example of a sort of an optional extra on top of that?
Optional extras are usually in form of avionics, so advanced navigational system and things that support the pilot on long gliding flights. In the motor glider range, this is also systems that allow flying in weather that is, let's say, below average, low visibility, rain, and so on. Let's say what the aircraft structure goes, there's not too many options.
And finally, you're launching it at the end of the year, and what still needs to be done between now and then?
Right now, the hardware situation is fixed. We froze the design, so the hardware components will not change. We're now tweaking the software to make it as user-friendly as possible and the operation as carefree as possible. We do not expect from the pilots to be engineers to tweak every situation. In fact, we don't want them to be engineers. The product must be so mature that it is used literally at a flick of a switch and really safe. So this is what we're making sure now. We're testing out different software configuration and different ergonomics in the cockpit as well to see what works best. We will expand the testing phase so that also other people, not just test pilots, fly it and provide the feedback. And once this is done, we'll have a machine that's ready for the masses, so to say. This will happen in the next half of the year.
How many do you anticipate selling maybe in 2009? You've already had over a dozen orders.
There's probably more until this point. There's actually owners who are waiting for the internal combustion engine version of the Taurus 503, who want to convert to electric. So the demand is large. We're seeing more and more, let's say, demand every day as we go by, especially now with the publicity. You're also helping us.
Well, thanks very much for talking to us. It's very exciting. We look forward to seeing all the developments over the next couple of years with your company and with products like this. So all the best luck with that.
You're most welcome. Thank you for the interview, and do drop by. I'm sure that we'll have some exciting news in the coming months as well about the Electra and some other projects we're working on.
Thanks again.